afternoon, Ecet210. I'm Ricardo Lupercio. I was just reading up on the discussion post that Professor Mukri posted up about digital multimeters and measuring AC voltage versus DC. Right now, as you can see, I have a Fluke 189.2 true RMS multimeter. I have my leads connected to a 120 power source right here, standard one you find here in the United States. And I also have my oscilloscope hooked up to my DC power supply, which I have running at 20 volts right now. If we look over here at the Fluke 189, we see that we're reading a value of 123 volts AC, but that's the true RMS value. So that's the power that's coming out of that outlet in order to power up your devices such as these. But that's not the true value of what's being sent out here, or in other words, the peak voltage is actually going to be different. The cool thing about this multimeter is that we can actually see what that value is, because right now it is displaying the true RMS value, so the root mean squared is already calculated and being displayed. So let's just go to the menu, and I'll go to peak. And as you can see, although we're getting 123 volts RMS, the peak values are closer to 170. The peak value max was measured at 172.3 at 0.000 seconds, and peak minimum was measured at negative 171 at that same time, with the average in 23 seconds being 123 volts. You could also refresh that, restart it, and we see that the values are still similar to, are still the same practically. Let's go ahead and stop that. What was that? Another cool thing I love about this multimeter is that I can actually go and measure the frequency. And as you see, 59.9 or 60 hertz. And we can see that we have a pulse width of 8 milliseconds. So that's one nifty thing about the Fluke 189 that I own, that it is a true RMS unit, but it also allows me to see the other values, and it conducts the calculations for me. I did try to hook this up to my oscilloscope, but then I realized that with the voltage divider maximum being 10 volts, I could only get a maximum value of 50 volts being displayed, and I do not want to damage this oscilloscope because it was pretty pricey. So I just hooked up my DC power supply, and I'm going to measure 20 volts. And since this is a DC current, we're not going to get any frequency. I don't believe so, at least. But we should measure the 20 volts directly on there, and I'll show you how that looks. So now I'm sending in 20 volts, so we can see that the measurement line went from 0 to 20. This is 10 divided, so 10, 20. And we can see on the oscilloscope screen our average voltage, 20.7 volts, with our RMS value of 20.7 volts. And you can see that it's either calculating infinite frequency or no frequency right here. So that was pretty nifty. And we could also prove that with my multimeter. Let's go ahead and check that out real quick. Safety first. Course, put that to measure volts DC, and I should read 20 volts right away. There we go, and there you go, we got our 20 volts. Now this is gonna be kind of tricky. Let me see if I can get a frequency measurement. You're supposed to have them clamped down for frequency, as far as that's what I've always been taught. Let's see if we can get a frequency, accurate frequency count right here, and it should be nothing. 0 hertz. Yeah, see, it's not picking up any frequency. One thing I did find interesting when messing around with this, and maybe Professor Mukri could help explain it, I've only been able to figure out as maybe some interference from the fan that's inside here, but if I put both my leads together and I get 0 hertz, if I lift up the negative, it'll show me the 60 hertz. And vice versa. There you go. So I don't know what to attribute that to. I think it could be maybe the interference from in here. According to the oscilloscope, we got no frequency. When we have both leads put together, we got no frequency. But yeah, so this is just a quick little setup that I have here, and just referring back to the discussion post that Professor Mukri had posted about the difference between using your test equipment, in our case the digital multimeters, when measuring AC voltage and when measuring DC voltage. And you can see that there's clearly a difference in knowing how to use your test equipment in order to get the proper results, which is very important in the technician level, or if you end up becoming the engineer, you need to make sure that the guys who are working with you and you're working with know how to use the equipment. That way you're not stuck troubleshooting a problem that doesn't exist or creating a problem itself. Alright class, thanks.